Hello everyone, this is Mr. Razak, and today we're going to go through dependent events. Dependent events occur when the outcome of the first event affects the probability of the second event. A classic example is drawing two cards from a standard 52 deck without replacement. So if you look at the first event, drawing an ace on the first try would be 4 out of 52. The reason why it's 4 out of 52 is because 4 are the total number of aces we have in a deck of cards, and 52 are the total number of cards we have in a deck of cards. Now, let's look at event B. Event B would be drawing a second ace. Because the first ace wasn't replaced, there are only 3 aces left out of 51 total cards, so the probability now becomes 3 out of 51. Let's look at a different example. There are 3 red counters and 7 blue counters in a bag. A counter is chosen at random and not replaced. Another counter is then chosen. How about we translate all of this information into a probability tree diagram? So you can see a probability tree diagram in front of you. Let's try to fill this. So you can see that we've got 2 picks. So first pick and second pick. In the first pick, the probability of red would be 3 out of 10 because there are 10 counters in total. And blue would be 7 out of 10. If in the first pick, red was chosen, then in the second pick, one of the red would go down. So as in, instead of 3, we will have 2 out of 9. And if the first pick was red, then blue is not affected. Therefore, it would be 7 over 9. What if in the first pick, it was blue? So what if it was blue? Then red is not affected, so the probability of the red would stay as it is. It would be 3 out of 9. What if it was blue? Then blue is affected, so then it would go down, so it would be 6 out of 9. Notice that the denominator in the second pick is 9, 1 less. That's because we had 1 pick, so it doesn't matter whether it's red or blue, there would be 1 less counter in the second pick. Now, using the probability tree diagram, we're going to answer this question. Work out the probability of choosing 2 blue counters. Coming over here to my probability tree diagram, we can see that blue is over here. So that's the probability of the first pick being blue, which is 7 out of 10. And the second pick being blue is 6 out of 9. So we'll multiply both of those 2 numbers. So probability of 2 blue counters is equal to 7 out of 10 multiplied by 6 out of 9. 7 times 6 is equal to 42. And 10 times 9 is equal to 90. And you can leave your answer like this because in probability, you do not need to simplify. Let's look at a different question. It says, work out the probability of at least 1 blue counter. So the probability of at least 1 blue is equal to, so if in the first pick, if it's red, then in the second pick, it must be a blue. So that would be 3 out of 10 multiplied by 7 over 9. And another scenario that we could have is, what if it was blue first, then it must be a red. So it would be 7 over 10 times it by 3. I believe this is 3. Yes, it's 3 over 9. Now, let's simplify this. So 3 times 7 is equal to 21. 10 times 9 is equal to 90. Add 7 times 3 is equal to 21. 10 times 9 is equal to 90. Add the numerators, it gives me 42 over 90. Okay, at this point, you can pause the video and try to do this question yourself. When you're ready, resume the video. Hopefully by now you have attempted this question, so let's go through this together. There are 8 counters in a bag. 5 of the counters are red, 3 of the counters are blue, 2 counters are taken at random from the bag. Work out the probability that 1 counter of each color are taken. You must show your working. So, the first thing I'm going to do is I'll draw my probability tree diagram. So that would be red, blue, again red, blue, red, and blue. The reason why I'm doing it this way, because it says 2 counters, so we'd have 2 picks. So this is my first pick, and would be my second pick. And let's add the probabilities now. 5 of the counters are red, so we'll say this is 5 out of 8. And 3 are blue, so it would be 3 out of 8. Let's add the probabilities for the second pick. If in the first pick it was red, then this would go down to 4 out of 7. Blue is not affected, so it would be 3 out of 7. Red over here in the second pick, let's just assume if it's not affected, then it would stay as 5 out of 7. And if in the first pick blue is picked, then this would be 2 out of 7. So this is my probability tree diagram. Let's work out the probability that 1 counter of each color are taken. So that would be probability of 1 counter of each color is equal to, so if it's red, then it must be blue. That'd be 5 over 8 multiplied by 3 over 7. Another possibility could be, well, if it's blue, then it must be red. So it would be 3 out of 8 times it by 5 over 7. 5 times 3 is equal to 15. 8 times 7 is equal to 56. And then again, 3 times 5 is equal to 15. And 8 times 7 is equal to 56. Add the numerators, becomes 30 over 56. And that is my answer. Anyways, thank you so much for watching this video. If you have any questions or any feedback for me, then please leave it in the comment section below. I'll see you in the next video.